Wait, let's go. Did you get that one wrong? Oh, yeah, you got all that, right?
You're finishing up this warm-up, these three problems. Have three names already chosen. Okay, Gideon, could you tell us what you did for B?
I did G equals -6 squared minus 4 times 9 times 1.
Did you put the -6 in parentheses like that? Nice, okay.
And so that got me 36 minus 36. And then that 0, which means that there's one real solution.
One real solution. Are we good? My abbreviation for the solution is normally that. SOL apostrophe N. Thank you, Gideon. Joseph, help us with C, please.
64 minus, like all under the square root, 64 minus 4 times 3 times 7.
Should I be including the square root?
Yeah, the square root, like all over it. No. Wait, no. Oh, shoot, yeah.
It's just a discriminant, just the contents of the radical. Okay.
Then 64 minus 72.
Is it 72?
4.
I'm going to do it 21 times 4. Do you mind if I just write it like that?
4. So then,
Do we actually have to figure out what that is, or do we know it's going to be positive or negative?
no, sorry, I didn't have a chance to figure out. It's to those I'm helping.
No problem. I'm just wondering, like, do we know already that this is going to be positive?
Oh, we already know that it's gonna be negative,
I
so,
know.
because 21 times 4 is greater than 64.
Are we good with that?
So then it's gonna be 2 magnets.
Nice. Right, this is less than 0. Therefore, there are 2 imaginary solutions. Some great behavior for lunchtime. Now, it does say to compute the discriminant, so we should be able to continue that 64 minus 84 is what, -20? And then that is less than 0. But if we just say it says to calculate or figure out, or use the discriminant to find out how many solutions there are, then you just have to go as far as you need to go to figure out if it's positive, negative, or equal to 0. Joseph, thank you. And Mia Rose, D.
I did 5 squared minus 4 times 2 times 17.
You do -5 squared?
Yes. No.
Oh, well, actually, did you do something to this equation before you did this? Did you change this at all?
Oh, yeah. I subtracted it.
Okay, so you made it 2x squared minus 5x minus 3 equals 0. And then you said D is equal to. I think it works out to be the same thing, but I'm going to bring that negative along for the ride. -5 squared. Thank you for bringing along that -3. Okay.
25. And then it's 49. So you have 2 little solutions.
At 49, we have to say that is greater than 0. Therefore, 2 real solutions. Thank you, Mia Rose. Any questions? And Joseph, thank you for reminding where the discriminant comes from. It comes from the quadratic formula, that which is under the radical, but the radical doesn't come along for the ride when you're looking for the discriminant. It's just the contents of the radical. Okay, let's get a move on, shall we? We've got stuff to do. And I want to give you time today to work on like homework and stuff. So what are the three letters we were using in this chapter? The Z, ZBB, the zero product properly, broccoli? What? No, ZPP, the zero product property. Anytime you're solving a non-linear equation, meaning the degree is greater than zero. Not, well, linear, what is the degree there? One. So if I'm saying non-linear, that means the degree is greater than one. Like this. This is non-linear. So we're going to use ZPP, which means first order of business is make a zero. Exactly. You feel okay? You're becoming a cartoon character, Luke. X to the fourth minus 27x squared equals 0. And the next step? Factor, yes. Draw it out. We're going to draw out as much as we can, namely the 3 and the x squared. Oh, look at that loveliness. A vision of beauty. That's
Mr. Weedon, so why couldn't you pull out like from the start instead of making this? Why could we just pull out 3x squared to begin with? Because you get the same answer no matter.
You mean like divide it or pull?
Yeah, so like I just started out by dividing the whole each side by 3x squared to get x squared equals 9, and you've reached it to get x equals plus 9.
Nice. So you lost the solution.
Which one?
The one that's not there.
Of 0 because it's a
Okay, so can I use ZPP in this form already? I think I could. 3x squared equals 0, x squared minus 9 equals 0. Have you ever solved an equation like this? You can factor it, but you could also say x squared equals 9, therefore x equals plus or minus 3. Haven't we done that? So you can do that. Or you could factor it into x plus 3 and x minus 3. And from here, we get that x is equal to 0. So we have three solutions. X equals 0 plus or minus 3. Sorry I got so scrunched in there. They didn't give us a lot of room. I wrote a little bit big. Any questions? I bet you brought up a good point. You can divide by anything but a variable. Please never divide by variables. So if you want, you could start off and say, hey, I could divide both these sides by 3 to get the x to the fourth equals 9x squared. But if you divide by x squared, then you get x squared equals 9. And you can see that. And don't copy this down, folks. This is terrible, man. Here, the solution is just 3 negative 3. I've lost the 0. So please do not divide by variables.
You can't divide by variables.
You could divide by regular numbers. Preach. Thank you. I'm going to write this here. Never divide by a variable. Luke, is that you singing? Who's singing now? I'm pretty sure it's not Ethan. I just put that up there.
What a good guess.
Thank you. Okay, for C, I'm gonna skip B because you could do that on your own if you like. C, first order of business is set it equal to 0. So we could use eventually ZPP. Are you down with ZPP? Thank you. Actual answer is yeah, you know me.
Oh.
How are we gonna factor that with four terms?
Group.
Group, yeah, by grouping. Yeah, I'll give you a moment. Check with your neighbor. I do want to call on someone in just a few seconds. Okay. The man who has not been singing in class. Ethan, can you help me out with this one, please?
X squared, parentheses, x plus one. Minus four, parentheses, x plus one.
Any questions? Thank you, Ethan. That was done like a boss. Very nicely done. Just as an aid in saying this, you can say x squared times the quantity of x plus one. Rather use the parentheses. And thank you for including the parentheses on this. I saw a few people doing this in their factoring after they did grouping. Do you see that that says something different? Right, that's only multiplying by that four right there, the negative four. I need to make sure, you all need to make sure that that is grouped. Now let's make sure, is this really the same as what we started with? And do you see the x cubed? Do you see the plus x squared? See minus four x?
Yep.
And the minus four?
Yep.
It's all there. It's perfect. E. Does this bring back good memories?
Oh.
Yes.
James, extra credit for you. Luke, I'm taking away your extra credit. Okay. Okay, I don't want it anyway. What am I going to do with that denominator of the right side? Factor it. What am I going to do with the top? Can I do anything with it? No, it doesn't factor. Okay. I get the feeling that factoring is kind of important in this class.
Yes.
Kind of like a essential skill. I'll give you a moment to finish this.
Can't we put everything under x minus and x plus one? Like, why can't we?
Combine those two fractions on the left.
Yeah, the left, well, we can make the left side like be x minus four and five x minus three and simplify that all over x minus seven x plus 12.
Okay.
Wait, do we use z?
Eventually, but not yet. Oh, maybe not for this one. Oh, no, you do. Check it with your neighbor. Okay, who'd like to help us with this? What am I looking for? Inaris? Yeah, do the first part. Joseph, one moment, please. I know you're working, but I'm sorry, Inaris. I need all attention up front listening to Inaris, please. Thank you. I'm so sorry, Dad.
Okay, so then you're gonna multiply 3 over x minus 3 by x minus 4, it's top and bottom. So we have that common denominator.
Okay.
5 do x minus.
Okay.
Now, everything related. So you can just like.
So since all the denominators are the same, we kind of ignore them now? Is that what you mean, or? Kind of. So we could say like this first one is, what did you write?
3 times, oh, well, we can do 3x minus 12. And then plus 5x minus 15 equals x squared minus 1. And then you know, all of these fractions.
Okay, so this is all like here, x minus 4, x minus. And we could do this. Does it make sense that this is kind of the logical next step? That's not really necessary. Like it could happen in your head. Because you have a fraction on left, fraction on the right with the same denominator. So let's just ignore the denominator and say that if the denominators are the same, then the numerators must match. Really nicely done. And from here, what property are you going to use? Oh, let's combine like terms, of course. They combine like terms property. 27 equals x squared minus 20. I like that. X squared minus 8x plus 7. So I can put the equals 0 over there, or I could put it over here. I'll keep it like that.
And then we know that x minus 7 and x minus 1. 7.
Any questions? Are both of those okay to use? Remember, in a rational equation, make sure that neither one results in a 0 in the denominator. That would be something you'd have to exclude. But yeah, neither one does, so you got it. Thank you. Very nicely done. Any questions? Okay. Yeah. How easy is this problem? Do you agree that this is super easy? It's like kind of, what grade could you have done this in?
Yeah, I think we should do a whole test going just.
You definitely could have done this in 7th grade. Am I wrong? As soon as you learn what a square root is, when do you learn what square roots are? What grade was that? Was that 8th grade? 5th grade? Did you learn in 5th grade? Some of you? 7th grade?
7th grade.
Square root is fine.
Yeah.
Okay, well, whenever you learned it, hopefully right now it's not difficult to know that the answer is x equals 81. The thing is, I don't want you to do it elementary school style. I don't want you to think about this elementary school style. Square root of what equals, you can, and quite easily get the answer 81. But I just want you to use algebra, specifically, Ben, what was it you said we should do?
Square each side.
We square both sides. Yeah, what I'm looking for here is for you to trust algebra. The square root of x squared is x, and 9 squared is, what a shocker that x equals 81. I know, mind blown. Okay, so we go here to do the same thing. We square both sides. And we get that x equals 9. The thing is that true? Is it true that the square root of 9 is equal to -3? It is not true. Luke, you okay? It got a little hot in here, isn't it? Nice cape. Oh. Yeah, so sometimes algebra fails you and leaves you with what kind of an answer? Or what kind of solution?
Wrong.
It gives you an answer that doesn't work. It's called extraneous. Extraneous solution. Algebra leads to it, but it doesn't work. You have to cross it out. And hopefully, just by looking at it initially, you could have seen, oh, there is no solution to that. Does that make sense just looking at this? There's no solution. You could look at it and say no solution. Of course, we're doing a very simple example of a case where there's no solution. There are more complicated ones where it's not obvious by looking at it. So anytime you have a radical equation, you must always, that's definitely not how to spell always check your solution. Exclamation points and underlining always. So you can see that A is no longer doable in a 7th grade mind, at the way that you may have done A. But we're going to go about it the same way. Step 1, though, is to move the 2. Let's get that out of there by subtracting. 2x minus 1 equals x minus 2. Next step, square both sides. I'm going to square the left, and I'm going to square the right. Notice I put the parentheses around that right, so I don't forget to expand the entire binomial. The left, what's that? Say that again, Inaris.
How would you like us to,
As long as the next step is correct, I'm happy. And the next step, well, finish it up, check with your neighbor, make sure they did it right, and then finish the question. I will be calling on someone to help us out with the rest of this. I ready to be called upon. Do you want to check first? I don't want to surprise you. Don't forget you have people. Ethan Jasir, don't forget about Upton behind you. Otherwise, he's all alone. You ready? Horn ready, I like it. Upton, you have been chosen. Can you help me finish this, please?
Yeah.
He's just so chill about it. We love it. Yeah. Okay, so we're squaring that. We get x squared minus 4 x
4x minus.
plus
Okay, then plus 4.
plus 4. Are we okay with that? Are we into the 3 terms? That comes from the a minus b squared. That's equal to a squared minus 2ab plus b squared. If you hate that, you could always do a minus b times a minus b, but don't just distribute that square. It's definitely going to be wrong. So we just switch things up on you. Are you okay finishing this up?
Yeah.
Okay, help me out.
minus two
Nice.
plus one. X squared minus six X. Then plus five. And that would be in parentheses X. Maybe X minus five and X minus.
It's working out much better now, isn't it? Okay, so we get X equals. Did you already get that, everybody? If you didn't, it doesn't make sense. Are we done with the problem? Don't forget, always check your solutions for the radical. So let's do the quick check. X equals 5. Okay, check X equals 5. We have, what is that, square root of 9? Do you see where that came from? Plus 2. Does that equal 5? Is that true? Okay, so 5 works. How about X equals 1? We have square root of 1 plus 2. Does that equal 1? Not in this country. The country where things are not true. The country of Oz. Yeah, not true. So X minus 1 just doesn't, X equals 1 does not work. You have to cross it out because it's what kind of a solution? It's extraneous solution. You're checking with your neighbor. What's a nice way to save this? What's a nice way to save this portion right here? Quietly checking with your neighbor. Now, what's a nice way to say it? Without even the word parenthesis. Parenthesis.
Five, it's X minus one. Yeah. Multiply. I would never use that word.
Okay, so what's the way? What's one way? There are several ways. Multiply. So the quantity of, there you go, the quantity of X minus 5 times the quantity of X minus 1. Any other ways? Since we're factoring, would it be okay to just say X minus 5 times X minus 1?
Yeah.
That's fine. That's fine. Just make sure that you're writing it in parentheses. But just mathematically, precise would be the quantity of X minus 5 times the quantity of X minus 1. And we're not going to do that. I'm going to let you do that. Well, I'm going to ask you to do that right now, please. I was going to leave it for a treat for later, but why wait? I mean, someone got it right. Check A. Oh yeah, I took that 5. I plugged in here, so that's minus 1, which is where the 9 came from. Plus 2 equals 5. I just put that in each fraction of the equation. Yeah, always the original. Check it with your neighbor. Destiny's about to call someone.
Doesn't talk.
One lucky individual. Is it you? We'll see. Only one person knows.
13.
Two? Oh, you, oh. I forgot about that guy. Ten seconds. Okay, Diane, help us out, please. Okay, so we get x minus 3. Okay. So it's what? Plus 6. Okay, equals 0. Ah, you caught it midstream. Nice. Okay. You can do this now. So you're looking for two numbers that multiply to be positive 6 and add to be negative 7. Okay. Oops, x minus 6, do you say, or 7? Oh, what just happened there? X minus 6. Okay. Thank you. Okay. Are we done?
No.
I have to check it. Let's check. Which one should we check first? Okay, x equals 1. So that leaves us with square root of 4 plus 3. Does that equal 1? Negatory.
Oh, no.
Nope. Let's check x equals 6. Does it work? It's square root of 9 plus 3. Does that equal 6? Yes, it works. Yeah, it has to. X will never equal 1? That seems really sad and a huge blanket statement. Yeah, who would do that?
That's too long.
I don't know if we could extrapolate from just these two problems. Okay, we got some time for a little stretch. I will resume at 1:10. I'll give you a little extra today. I think what you mean is, oh no, we have to wait longer. Yes, it was. Yeah. Sure. Oh, I like that.
Then with,
Are we gonna do the calculation?
We're not definitely not going to use a calculator. I'm checking your homework right now to see.
oh, okay.
After looking at the assignment, I realized I'm done with the lecture, so you're more than welcome to go at it with your homework if you haven't started already.